enough to understand what's going on here. So now the first thing is to understand the theorem, like how can we make sense of the theorem. So this D'Alembert ratio test a series form of AR. Now this is AR, meaning there's a AR here. This term, I don't know what formula is this. Okay, converges when limit an plus 1 to an modulus is less than 1, when n goes to infinity, and diverges if it's bigger than 1. Okay, so let's try and make sense of this. What does n goes to infinity mean? And what's the implication? Now, first of all, if this is an, then this is an plus 1. If this is the current term, this one will be the next term. Okay. Now what it says is this. As n goes to infinity, let's see if you draw this number line here. N. So let's say n goes to infinity. This is this will be an. Okay, maybe I'll just an and an plus 1. Okay. Now it says that if an plus 1 over an is less than 1, okay, this is important. This means that the next term over the current term is less than 1. Okay, the next term, when you, okay, if the next term over the current term is less than 1, which one is bigger? The next term or the current term is bigger? Obviously, it's the current term is bigger, right? Because in order for you to get less than 1, your current term is actually bigger than the next term. So this case here, this an will be slightly bigger than the an plus 1. Okay, make sense? So essentially what you're saying is, okay, if your next term is smaller, then you will converge. Does that make sense? It makes perfect sense. What? It's exactly what you would expect. What? It's just that it's written down in mathematical form. Okay? It's just, it looks cheap, but it's the same thing. That's the beauty of maths. How do you express natural stuff? How do you express conceptual stuff into math, right? So that's the idea. So this same thing, this tells you that the next term, because if an plus 1 over an is bigger than 1, it just means the next term is bigger than the current term. You expect is larger. Okay? So if n goes to infinity, the next term is larger than the current term, would you expect it to converge or diverge? Diverge, right? Shouldn't be a rocket science there. So that's what it's trying to say. So you try and understand. This is like reading comprehension, but ending reading comprehension in math. Okay, so then that's about it. So now then after that, an plus 1 over an is equals to 1. Okay, now this one you expect it to be a constant term, but it's actually inconclusive. There are cases where sometimes we may think that you can conclude, you can't. Some math, I mean you know that math sometimes it's not conclusive. Okay, but this one is just extra because later part of the question they will never ask you to show the inconclusive part. Okay, but I know we all would assume that it's a constant term. I mean it just becomes the same term all together, but it's not. Sometimes it will just why? Because if an plus 1 over an modulus is equals to 1, it means that an plus 1 and an can always alternate. Let's say an is minus 5 and an is 5. It also can be equals to 1. Okay, so maybe this series can be minus 5, 5, minus 5, 5, minus 5, 5, minus 5, 5. At any juncture you take, it will still be 1. Okay, that's why it's inconclusive. But never mind, we put that aside. Now, using the test, explain why this series converges for all real value of x and state the sum infinity of this series in terms of x. Okay, so if you're converging, you are looking at the one converges here. The divergence one don't care. Nobody cares about the divergent one. Right? You just look at that small part. This is the kind of question which will separate the A star student and the A and the B student. Okay, so this is really like the one which uh you leave it to the last to do lah. But even if you can't do it, fine. Just try and write something up. Okay, in the exam. Okay, so we understand the question with a clear picture already. So now the important part is, of course, we want to evaluate what is the AR term. Means this AR here. Okay, this is the AR term here. This is important. AR, because we want to examine. Actually, it's more precisely it's AN plus 1 over AN. So we just take that log. So for this one here, this one, R equals to 0, and this is X R infinity. Let AR, yeah, right, goes to X R over R. So what we need to evaluate now is essentially just limit n to infinity. Then we just need just copy whatever is given an plus 1. This is the deciding factor. We want to know what is the ratio of the next term to the current term modulus. That's about it. Okay, so we hope that this goes to 0, less than 1, less than 1. If it's less than 1, then yeah. So AM, this will be limit n infinity xn plus 1 over n plus 1 factorial over xn n factorial. Slowly. Factorial is fun to play. We really like it. I mean, we've done a huge portion of it in stats. And just multiply by n factorial over xn. So you can actually split up the larger one, which is n plus 1 factorial. N plus 1 factorial is n plus 1 plus n factorial. N infinity to be n plus 1. This is x. Then you just simplify them. What you get is not many like the concept, like you see simple things that I kept on regurgitating. Things like I say an is the current term, an plus 1 is the next term. If you keep knowing this stuff, it's just looks chim, but you break it down, it's not that difficult, okay, to understand. So this will give us the ratio of a next term to the current term. And it's not hard to see why this is, because when n goes to infinity, this will go to 0, right? Okay, this is 0. But the term below it becomes so large. X is not changing. X is just another arbitrary constant. It's just an arbitrary term there. So this is 0. What are we going to do next? So hence, by our Lambert friend here, a Lambert by which is less than 1, this one. Less than 1, right? Series is series converges. The last one state the infinity of the series in terms of x. So what you do is you just write this down. If you can't see it in sigma notation, always expand it. So you just slowly do it. This is x0. R is 0. Plus 0 factorial is 1. So I think you already encountered this. You know that 0 factorial is 1. So this is x1 1 factorial plus x2 2 factorial plus x3 3 factorial plus x4 4 factorial to beyond. So this series here, if you look carefully in your MF26, okay, so it's actually under here. One x. This is for MF26. That's it. MF26, infinite series.